Number 16, we're supposed to graph the equation 3y plus 4x equals 12. Now, in order to graph, we talked about making a table of values, and it's a lot easier to make a table of values when you have y solved by itself, when you have y as a function of x. So in class, we talked about fence posting first to get y by itself. If we want to get y by itself, the first thing we have to get rid of are the x's. To get rid of a plus 4x, you would subtract 4x from both sides. And when you do that, you end up getting 3y equals 12 minus 4x. We're close. To get rid of the times 3, we divide by 3, but if you do it to one side, you have to do it to the entire other side. So what do you end up with? You get y equals, if we earthquake this and split it into the two pieces, 12 divided by 3, that's 4. Negative 4x divided by 3 doesn't work out so nice. We can't really reduce that fraction, so we're going to just leave it as negative 4/3 x. Now, when we go ahead and make our table of values, they didn't specify a domain in this problem. Okay, they didn't say you have to plug in certain numbers, so it's free reign. We can pick any x values you want. I always recommend picking 0 because it's easy to multiply by 0. 4/3 times 0, that's 0. 4 minus 0, well, that's going to give me 4. You can pick any other x values you want to calculate the y. You plug it in. But let's try to make our lives simple. Notice we're multiplying by 4/3 here. So if I were to multiply by any multiples of 3, it would cancel nicely with this division by 3. I mean, you could use negative 1 for x or 1 for x, but then I'm dealing with fractions. I like to stay away from those when I can. So let's plug a 3 in for x. So you'd have 4 minus 4/3 times 3. Well, 4/3 times 3, if you times 3 and divide by 3, they cancel each other out. So really you just get 4 minus 4, which is going to be 0. I'm going to do one more multiple of 3. I'm going to choose negative 3. So if I plugged it in, I would have 4 minus 4/3 times negative 3. Well, minus 4/3 times negative 3, the 3's cancel. Negative 4 times another negative. A negative negative makes a positive. So really you end up with 4 plus 4. You get 8. If I'm ever fishy or whether or not I've graphed this right, I can plot the 3 points, and if they're in a line, I'm probably okay. 0, 4. 3, when x was 3, we got 0. And negative 3 gives me 8. Negative 3, 8. I look at these 3 points. They're in a nice line. Chances are I graphed it correctly. The last step, since they didn't specify a domain, I need to connect the dots and show that I can go anywhere, that there are an infinite number of solutions that make this equation true.